So welcome everybody to this first webinar in the Spring Open Topography webinar series. This is something we put together to try to highlight Open Topography and to talk about sort of lots of different features and functionalities and answer some questions that we get on a regular basis via email about features and functions and other things. So my name is Chris Crosby. I'm one of the co-founders of OpenTopography, and I'm responsible for management of quite a few of the day-to-day operational things about OpenTopography. I'm joined here by some other members of the OpenTopography team who are acting as co-hosts, moderators, and are going to be helping answer questions. So just to remind everybody that we sent you an invitation to this webinar series, and it was a calendar event. So this is actually 8 separate 1-hour webinars we're going to do over the next 8 weeks, starting today, running at this exact same time slot. And the idea here is that we're going to start with a pretty high-level overview of what OpenTopography is and sort of broad brush some of the features and functions and other things you may find interesting. And then in the following weeks, different members of our team are going to present on different topics with a slightly deeper dive on various things. So we're going to do sort of intro to what OpenTopography is and how it works today. And then the next 2 weeks will be led by Matt Beckley. And we're going to talk more about the data types that are in OpenTopography, things like point clouds and where they come from, digital elevation models. And then we'll move into some other more specific tools and functions and analysis things inside of OpenTopography. And then at the end of the series, we're going to wrap up on kind of education and training resources that are available through OpenTopography and some discussion of 3D printing and iPhone LiDAR, some sort of fun topics that Emily will lead at the very end of the webinar series. So that's kind of the overview. The idea here is that these sort of build on top of one another. So we're not going to do a what is OpenTopography intro to every single talk. So we're going to assume that people are attending. We also appreciate that everybody can't make it to all of these. So we're going to record these and stick them on YouTube, on our YouTube channel. That'll probably happen within a few hours of the end of the webinar. So if you miss these or you want to share them with colleagues, feel free to do so. Couple of basic logistics. This is a Zoom webinar. So right now we have it set up such that only the moderators can speak and have their cameras on. So what we're going to do is use the Q&A function inside of Zoom. So as we go along, please feel free to put your questions into the Q&A as clearly and concisely as possible. And then for simple things, one of our other team members, colleagues here may jump in and answer the question on the fly. Things that need maybe more discussion or a broader topic of interest to maybe more people will hold till the end of the session. If for some reason we have a technical issue and we crash Zoom or something like that, please just click back through and we'll jump back on or restart if we happen to have that scenario. So it looks like there are about 138 people in here now, which is great. We had a lot of interest in this webinar series, who surprised us by how many people were interested. And we know that there's a lot of diversity in terms of the user community of OpenTopography. So our core community, we tend to think of as the academic community, but we know when you all registered, you self-identified as commercial sector, academic, governmental, or some other category. And so we know we have quite a bit of diversity of participants. Some of you probably are pretty heavy OpenTopography users, and that's great. Some of this may seem like very review for you. Other people may be new to OT or maybe haven't visited us in quite a while. And so there may be some interesting updates that we'll cover. So what is OpenTopography? That's where we're starting. The project is really designed to democratize online access to high resolution topographic data. That was our original mission. That's still our primary focus, are what we consider high resolution. So this would be like meter pixel resolution data or better. But we do also have quite a few, I think like 13 or 14 global topographic data sets that are lower resolution. These are sort of 30 meter per pixel type resolution data sets and actually get a lot of use and interest in those data sets as well. And so we'll talk about both of these things. These are data sets that come from technologies like LiDAR, photogrammetry, and in some cases, satellite-based platforms, either photogrammetric or radar-based platforms. And OpenTopography is really interested in distribution of those data sets, but also in co-locating those data products with tools and functionality to derive products and make the data easier to use. And so this is one of the themes you'll hear throughout the course of this. presentation. So who are we? So OpenTopography is a small collaborative project supported primarily by the US National Science Foundation, specifically the Earth Science Directorate at NSF. So the folks here you're seeing pictures of is the team, Vishu Nandagam at San Diego Supercomputer Center, myself at EarthScope, Ramon Aerosmith at Arizona State University, and Chelsea Scott at ASU are the project co-PIs and the leadership team. And then Min Fan at San Diego Supercomputer Center, Matt Beckley at EarthScope, and Emily Zawacki at ASU are the rest of the team and the folks who honestly probably do most of the real work around here. The project is, again, supported by National Science Foundation and is a collaborative project. So a lot of our technical compute infrastructure is at San Diego Supercomputer Center, which is an academic computing facility at the University of California, San Diego. EarthScope, where I work, is a consortium nonprofit primarily supported by the National Science Foundation, NASA, USGS. This used to be known as UNAVCO and IRIS, but we merged recently. So if you've been around OpenTopography for a while, you may have seen things with UNAVCO branding, but as of January 1st of this year, we're now a new organization called EarthScope. And then Arizona State University is the third leg of our partnership. And we've been doing this, working with these kinds of data since 2009. That's our first round of support from the National Science Foundation. But really a lot of the prototyping and sort of work that went into building OpenTopography and a lot of the motivations were really fleshed out in the mid 2000s. So there's a lot of history around OpenTopography now. It's 14 years of sort of production and we keep growing. And so I'll talk a little bit more about sort of some of that growth. What do we do? Primarily topographic data hosting and distribution. So this is centralizing data, acting as a clearinghouse for various kinds of topographic data, making data easy to find, easy to reuse, easy to cite. We do not collect data. We don't have laser scanners. We don't go out in the field and generally produce data. We sort of centralize and aggregate and host data and then provide this sort of compute resource to derive products on top of this sort of centralized data archive. So in terms of the derivative products, these are things like digital elevation models of various forms and then their derivatives, so hill shades, slope maps, things like contour lines, and then other higher order products. And historically, we've also done a lot of education and training in the use of high resolution topography. So I think we've run something like 35 different short courses. Over the years, we have a lot of online resources. And this webinar series would, of course, be sort of part of that, so that overarching effort to teach people how to better utilize these data sets. So the data, most people come to OpenTopography because of the data. And so this is a map showing the lower 48 and also high resolution topographic data sources. So if you've been to OpenTopography recently, it's opentopography.org/data. We'll take you to this map. There's just a screen capture of the map showing data. It's basically all the data that's available through OpenTopography and in this high resolution sort of space, colored by source. So data sets in red are OpenTopography hosted. These sit on servers at San Diego Supercomputer Center. These are the kind of more academically oriented data sets collected by National Science Foundation or other partners that we've built relationships with. The green and the dark blue are data sets coming from the sort of big mapping organizations in the United States, so the US Geological Survey and what is called the 3D elevation program, which is an effort to map the whole nation with LiDAR, is green. And then NOAA has a coastal LiDAR program, so data sets that intersect the coasts of the United States are also accessible through OpenTopography. And then the purple dots are smaller data sets that our users have uploaded and contributed. And so these are data sets that we have a thing called the OpenTopography Community Data Space, which is a publication platform primarily oriented towards academic users who are collecting their own data, say with a drone, and want to put those data someplace so they can be citable in a publication or use in a classroom or something like that. And then the thing that's not reflected in this map are the global data sets that are available through OpenTopography. So I'll talk more about that in a few minutes. There are 61 trillion points inside of OpenTopography. These are primarily LiDAR points, and they're primarily coming from the USGS 3DEP program, the NOAA coastal LiDAR collection. But there's also data sets from photogrammetry, which produce point clouds as well. And then there are these 13 global and regional kind of topographic data sets that are at lower resolutions. And all of this is accessible through OpenTopography in various ways. Again, for people who aren't super familiar with high-resolution topographic data sets, this is a small snippet of data from the Indianapolis Motor Speedway, home of the Indy 500. On the left is a screen capture of a point cloud. So this is individual XYZ laser bounces from the laser scanner. In this case, they're colored by reflectance or intensity of the laser return. So basically sort of albedo of materials in the near infrared. From those, so some people work with point clouds, but actually in our experience, a lot of people want to work in a raster-based sense. So working in more of a traditional GIS or geospatial kind of data space. That would be the middle. So a raster product, in this case, it's a gridded digital elevation model. This would be a digital surface model because it includes the buildings and the vegetation. So this represents kind of a grid of the top of the landscape. We call this a digital surface model. If the vegetation and trees and things were removed, we would call that a digital terrain model. In this case, this is a hillshade of that image. This is just imposing a artificial sun angle on top of that topographic grid. So this is a raster representation of the data. You can also look at slope maps and aspect maps and canopy height models and all these other raster representations of data, and OpenTopography does produce those. And then on the far right is a vector or a contour line derived from these data, and OpenTopography has tools to produce contour lines directly from the data. One of OpenTopography's specializations is really the fact that we have all the point clouds and we'll produce these products to the right of this on the slide dynamically on the fly from the raw data. So we're not pre-computing vectors like contours, we're actually making contours from data sets when you ask for them, which is nice because it gives you a lot of control over that product, allow you to change the parameterization and things like that. One of the original motivations of OpenTopography was to allow users to access data kind of at the layer they want it at. So there are power users and very advanced users who actually don't want a web interface between them and the data. They just want to grab the data and take it away and do things with it locally or process it in the cloud. And at the other end of the spectrum are people who actually just want, for example, a hillshade of a nice looking digital elevation model they can print out on a piece of paper and put it on a map board and take out in the field and draw lines as they're mapping a landslide or active fault or something. And so OpenTopography's motivations has always been to try to address users across that full spectrum of use cases. So everything from very easy to use products like perhaps a Google Earth KMZ file to direct bulk access to data sets through an API. We have a whole suite of different kinds of data services that sit on top of these data. So at the top left are things like making digital elevation models from point clouds. These are on-demand gridding of data sets, sort of at user-defined resolutions and specifications. Kind of other derivatives like hillshades and things like you would use to sort of look at the data or do additional analysis, slope. So yeah, tools to do on-demand calculation of canopy height. We make contour lines. We have a tool for doing 3D visualization of point clouds in the browser. Topographic differencing, so tools for calculating change between data sets exist in OpenTopography, and there's two types of this. There's change of the data kind of in the vertical, so Z direction change between two digital elevation models, or a full 3D kind of point cloud change. And then finally, tools for hydrologic routing. And I'll pause here and just say that if you look at the webinar agenda, we're going to do deeper dives on a lot of these things. So we have a whole webinar on topographic differencing, a whole webinar on sort of hydrologic tools, a whole webinar on 3D point cloud visualization. So again, the motivation for today is to sort of just do that overarching, like kind of broad brush, what is OpenTopography and what's in it, and then we'll hope you come back and join us in future webinars to learn more about specific things. So this is how OpenTopography works in a simple way through the web browser. So you can zoom in through an interactive map. You can use that select a region button in the upper left and see what data sets exist. You get a pop-up below the map that shows you the sources of data sort of categorized by where they're coming from. So there's kind of the core OpenTopography collection. There's data sets that we're pulling from USGS and from NOAA. There's the data uploaded by kind of just users in our community. These are the small data sets. And then there's the global data in that far right tab. Once you've identified which data set you are interested in, you can sort of dig into this a bit more and go after a specific data set in a subset. So one of the things that's nice about OpenTopography is you're grabbing chunks of data, not worrying about downloading tiles or having to put the data together outside. You're just saying, I want an area of interest. And in this case, we're going to do Mount Hood in Oregon, Cascade Volcano. You can also choose like a subset of the data set. So a lot of our point clouds in particular have a classification typically associated with them. So an algorithm has been run to differentiate a point as ground from vegetation or a building. And so that's a function you can choose as part of your initial query. Then once you've selected your area of interest, you can define what product you want the system to give you back. So you can say, I want a point cloud in an LAS or LAZ file format, or maybe ASCII. You want to grid the data into a digital elevation model, a custom digital elevation model. So you can do that through one of two ways, using either a triangulation, a TIN, or a local kind of moving window gridding algorithm. You can choose to produce derivative products like hillshades and color relief maps, slope, aspect, topographic roughness. These are all basic derivatives of the topography that OpenTopography will generate for you. You can choose to make the data viewable in the browser, make contour lines, and do some advanced analysis. And so this is kind of the core set of tools inside of OpenTopography. And again, when you click that submit button, these jobs run on demand. So we find the subset of points, the couple 100 million points you may be interested in, and we produce these products for you on demand. We're not going and getting pre-computed products. We're doing this. And so you can see there's a lot of control over the parameterization of these jobs. And that's nice. That allows you to kind of come into OpenTopography and turn the knobs on the settings and figure out which product is best for you and will best suit your needs. So, and again, you're using our computing power to do this, not locally. And most jobs in OpenTopography tend to run in hundreds of seconds to a few minutes. We like to say it's generally like a walk down the hallway and get a cup of coffee and come back, and hopefully your data has been processed. That's not necessarily the case if you're doing really complex jobs with lots of things, but most jobs run relatively quickly. When the job is done, you get a results page that has some information and links to download products. You also get an email, unless you choose to turn emails off. So you don't actually have to leave the browser open. You can go away and come back. You also have a My OpenTopography dashboard if you create an account, which we encourage you to do, and that's an archive of your jobs. So you can go back and see previously submitted jobs and rerun them or view the products and things like that. And so on this landing page, you can see there's downloads for point clouds, digital elevation models, some raster visualizations, and then this view the data in 3D in your browser option. So the results when they come back look something like this. So here's the system will make you these nice browse images, so you can just quickly look at the product. You don't have to download and bring it into GIS or anything like that. So upper left is a digital elevation model produced from the data using a triangulation. Then there's the color relief map, a color hillshade, and slope produced here. And these are all, again, easy to download and bring in later into other processing, or just use without. You can make that's a full. If you click those thumbnails, they're full resolution, so you could just copy paste into something like a PowerPoint presentation. We also have this cool free point cloud viewer, which is based on an open source product called Potri, and this allows you to quickly look at point clouds in the browser. So here's that same Mount Hood point cloud data set spinning around, and this is just a screen capture of somebody dragging and exploring this data set. So this is we're in a web browser at this point. We've not downloaded any data sets. On the left, you can actually change the visualization, so you can colorize the data by intensity or classification or other things. And so this is a very nice, powerful way to quickly look at data sets, handy for classroom uses as well. And we're going to have a whole webinar on this tool in particular, and also some other tools for looking at 3D point clouds. Here's Mount Hood again, more pretty pictures. This is the left is just a hillshade derived from the DEM, and the right is that color relief hillshade image. OpenTopo also will allow you to do things like choose to export a file as a KMZ, which is the file format that's used in Google Earth. So you can take that color relief image or color hillshade and double click the KMZ on the OpenTopography page and launch into Google Earth and visualize that product directly into Google Earth. It's really another quick and easy way to look at the data. It doesn't require any proprietary software. We also have a tool that will just open the image overlain on a Google map or something as well, if you just want to quickly look at the data. So these are very simple ways to interrogate and look at the data. This is Crater Lake, obviously. And again, all in the browser environment. Basically every image I've shown you has come mostly from the browser. We have these higher level tools that I won't spend too much time talking about now, because we're going to have to talk about them for a full hour in a couple of weeks. But one is tools for topographic differencing. So this is when you select data sets that have overlap spatially, we enable you to choose to compare them to one another or difference them. So this is basically looking at data set collected at timestamp 1 compared to timestamp 2. How has that landscape changed? And to do this, we compute this for you. And so this is an example from the White Sands National Monument in southern New Mexico, where there's actually been, there's been 3 data sets collected in this region that are inside of OpenTopography. And so here on the left is just one of those data sets in a hillshade. And then the image on the right is the difference between them. And so this is a dynamic dune field landscape that's migrating from the southwest to the northeast. And so these color bars show where material has been removed, so sort of erosion where the landscape goes down, and deposited. So this is dunes are propagating northeast in this image, so that you can see that there's material accreting on the sort of leading edge and being eroded from the backside. And so we computed this inside of OpenTopography. This job runs in 52 seconds. On the right is a 3D calculation. So this is a more sophisticated tool that's more specialized. And we'll talk, Chelsea Scott will talk a lot more about this when she talks about differencing. But this is basically looking at the change in a chunk of topography compared to the reference or compare data set in 3-dimensional space. And so these are vectors basically with a sort of order of magnitude displacement. This takes longer to compute and is very specific to a specific set of processes, but things like earthquakes work really well in this tool. Another tool that we have available that's more sophisticated, and we'll talk more about in a future webinar, is hydrologic routing. So this is using an open source product called TauDEM, developed by somebody named David Harbotton at Utah State University. And this is doing hydrologic routing. So this is similar to like ArcHydro if you're more of an ArcGIS person. And so we will do things like pit filling, calculate flow direction using either D8 or D-infinity algorithms, and production of these other products. And this is a somewhat cool tool inside of OpenTopography because it's physically running on a supercomputer. So when you run a TauDEM hydrologic routing job inside of OpenTopography, you're supercomputing. We have a dedicated allocation on a machine called Expanse at the San Diego Supercomputer Center that's being used specifically from this. And here's what a couple of those products look like once you get them. So flow direction and contributing area are 2 kind of common hydrologic products. And again, we'll talk a little bit more about these in a deeper dive in a future webinar, but these are some of the more specialized tools inside of OpenTopography. When you look at the OpenTopography Find Data Map, one of the obvious things is all these polygons that are green and blue. And so this is really a revolution in the last couple of years that's been enabled by these national mapping projects. The USGS 3-Depth project in particular has been going on for quite a few years now, but in the last couple of years, they've begun publishing this data into an Amazon Web Services public data set. So this data basically gets pushed from the USGS into this public repository, and then we have spun up processing inside of Amazon that allows us to put our set of processing tools on top of this public repository of data. And so this is data you all have access to through Amazon, but what the OpenTopography value add really is that you can use our tools on top of this massive collection. So there's approaching 2,000 specific USGS 3-Depth data sets and 831 NOAA data sets, 58.5 trillion points. And by I think 2026 is the target date to have the whole United States mapped, lower 48 mapped wall to wall with LiDAR and be available through this pathway. So this is super cool and has really filled out the map in OpenTopography. One subtlety though, for many of you, since I know some of you are not academic users at the moment because of our funding limitations, we have this currently limited to users who come from the academic environment. So if you have a .edu email address, you can access this when you create an OpenTopography account. If you're an international academic or a nonprofit user or an educator, not in the kind of university system, we have an application process where you can fill out an application and request access to this data. But this sort of data access with the OpenTopography value add is currently not available to governmental and commercial sector users. And that's really just simply because we don't have enough resources to support the many people who would want to pound on this data through OpenTopography. We're actively working on solutions to this. Got a couple different sort of business models we've been exploring and partnerships. But at the moment, we know this can be a little bit frustrating for some percentage of our user community. I saw that in the Q&A, and I think Matt or somebody answered already, was questions about international data. So in particular, OpenTopography, again, in part because of our US National Science Foundation funding focus is really US centric. However, we do have a partnership with Land Information New Zealand, which is the national mapping agency in New Zealand. And they're using OpenTopography to distribute their nationwide LiDAR point cloud data set. So much like the USGS 3DEP program, New Zealand's in the process of mapping the whole country. And as they do so, they send us data sets. So we get about a data set a month from Land Information New Zealand and publish them here. So there's 62 data sets, 940 billion points. And this is, if you're somebody interested in New Zealand or you're from New Zealand, I know this webinar is not time convenient for our Kiwi colleagues, but keep an eye on OpenTopography because there's a lot of data coming soon if it's not already in here. The other thing I'll add about data and sort of just finding out what's new is specifically for the NOAA and the 3DEP data sets, we sync with the Amazon catalogs on a weekly basis, typically on Fridays. So if you want to see what's changed, you refresh the OpenTopography data map on, say, Monday morning, and you'll see the latest and greatest as we sort of see new data sets come in. Some weeks there's quite a bit of new data, other weeks there's not. It just depends on what the USGS's workflow looks like. So the global topographic data sets is something I want to spend a little bit of time on because these data are really amazingly popular in OpenTopography. These are typically 30-meter resolution, although there's data at 90 meters resolution, and some of the USGS products are 1 or 10-meter resolution. But these are have always been interesting to me because these are data sets that you can get from lots of different places. You can go to a USGS clearinghouse, you can go to a NASA place. There's lots of different places to grab things like the shuttle radar topography mission data. These are like workhorses in the geospatial world. Some of these data sets like SRTM have been around for a really long time. But you can get them through OpenTopography, and you can put we've put a lot of the same tools that I was just talking about for the high resolution data on top of the global data sets. So you can do things like make a hillshade, calculate slope, you can run hydrologic routing, those kinds of things on top of these data. Each one has a slightly different spatial extent. So shown here is SRTM 30 and 90. A lot of these are largely space-based collected with the exception of the USGS 3DEP data sets. And so they have slightly different spatial coverages as a function of sort of the satellite or space shuttle geometry at the time and sort of what the top of the spatial coverage of the planet is. So you can see SRTM as kind of cuts off across southern Alaska. But these data sets are also accessible through an API and through as cloud native data called COGS, so cloud optimized geotiffs, and I'll talk a little bit more about those in a second. But this simple access to these is partially what has made this so popular, I think, for people. So here's a couple of just examples of what these look like. There's a DTM of Mount Fuji, Japan, sitting on top of Google Earth, and that's SRTM, shuttle radar topography data. On the right is Mount Etna, Sicily, and this is a relatively new product we just added to OpenTopography called the Continental Europe Digital Terrain Model. And this is actually an attempt to use machine learning to produce a bare earth topographic product for the whole of continental Europe. Many of these global data sets are not bare earth products because of the technology used to collect them, either photogrammetry or radar. They typically do not represent a true bare earth. So this is an interesting data set, this EU DTM. So you can get these data sets through the portal, through the GUI, draw a box on a map and download the data like I showed the screen captures of earlier, but we also have these API and bulk access pathways. So this OpenTopography Global Datasets API is a very simple RESTful API to provide you access to those 13 different global datasets, global or regional datasets through a simple RESTful command. This has been exceptionally popular. I think this thing's been hit like 3.5 million times. And it's also been embedded into a bunch of different software packages. So Blender GIS, for example, is a very popular open source package, and it pulls data directly out of OpenTopography. And so to use this, you have to get an API key. So you create an OpenTopography account, get an API key. That key is free. And then you can use the RESTful call wherever you'd like. And so whether that's in a scripted process or inside of, again, like a tool like Blender GIS. The other way to get these data are through these things called cloud optimized geotiffs, COGS. So a cloud optimized geotiff is just a geotiff, which is a very common raster format for geospatial data, imagery, topography, et cetera. And then this relatively new improvement is to make these data sort of cloud optimized, which means they have pyramiding and the ability to pull them and interact with them directly from a cloud repository. So we publish all of our raster data sets on OpenTopography in a cloud, an Amazon S3, basically protocol-based bucket that we maintain in San Diego. And you can use these data in lots of interesting processing workflows. And there's, if you go to our GitHub repository, Matt Beckley wrote a really nice notebook that shows you how to interact with these data sets and some of the analysis you can do by coupling the data in the cloud with tools like open source tools like GDAL to do kind of raster-based data processing, clipping, and other analysis. And so this is a really interesting pathway that we're encouraging people who want to do larger scale analysis to take advantage of. Again, free to use. Another thing inside of OpenTopography that I think some users are aware of, but we're constantly trying to steer people towards is sort of the metadata that's associated with these data sets, and in particular, information about how you properly cite and acknowledge and sort of comply with licenses associated with these data sets. So in the academic world, there's this term called FAIR, which means findable, accessible, interoperable, and reproducible data. It's OpenTopography is trying to make our data as fair as possible. So on each dataset landing page, at the top, there's a digital object identifier. This is a persistent URL that if you're citing an OpenTopography dataset in a publication or on a website or any place else, we really encourage you to use that DOI because it's a unique identifier that will always point to the data, even if for some reason we change our URLs in the future due to some architecture update or something like that. Every data set has a citation, which would be used for sort of more academic publications. So if you're using an OpenTopography data set in a publication, you should cite that data set and you should use the DOI, and we provide you the language that we recommend. If you're using the data in some other applications that's not so academic, but you want to provide credit for the use of the data, we provide acknowledgement language. So this can go in the credits of something, or sometimes people pull data from OpenTopography and use it in like video games or movies. And so we got emails like, how do I acknowledge this in the credits of my video game or whatever? And then the license term. So basically all the data sets in OpenTopography are open and free to use for various applications, but in some cases they have a acknowledgement requirement. So that's the CC BY 4 Creative Commons license. Basically says that you can reuse this data for whatever purpose you want, but you need to provide acknowledgement and credit for that data. And this is important for us as OpenTopography because we have to write a grant every couple of years to get renewed funding. And it's also important for the people who spend a lot of time and effort to get the resources and to collect the data. So we really value these kinds of open data, making sure you properly cite or acknowledge data sets. And this is broader than just OpenTopography. In any open data context is really important. And then at the bottom there is additional metadata information. So almost every data set in OpenTopography has some kind of survey report, which documents a lot more about the sort of actual physical collection of the data. That might be the instrumentation that was used, how the ground control was done, QA/QC, how the data sets were classified. All that information is in is in a survey report that you can find linked from OpenTopography. And then we also pre-compute a whole bunch of other metrics, things like point densities of data, what types of classifications are available, those kinds of things. So that's another piece that's inside of OpenTopo that we encourage you to check out. So quickly, I've already mentioned this, but OpenTopography use has kind of blown up. A lot of this is motivated by the Global Datasets API. We recently crossed over 100,000 registered users of OpenTopography and have run 1.7 million jobs. As I said, that API has 3.5 million hits. And there's actually over 62,000 people on our mailing list, which is why like 900 some odd people registered for the webinar series, which is kind of mind-boggling. For us, a really important metric is academic publications. So basically, how much has OpenTopography enabled new science? And so we track this really in a lot of detail since going back to our very beginning. There's been 746 peer-reviewed publications where OpenTopography data are utilized or data are cited or acknowledged. And this is growing every year. And if you're interested in that stats, we track this bibliography and we sort of publish a yearly update. So you can check that out online. One of the really interesting things about OpenTopography that we just like to muse on occasionally is just like the diversity of use of these data sets. These high resolution topographic data sets are really interesting for lots and lots of different things. Many of them far outside of what motivated the original collection of the data. And certainly what motivated us when we started building OpenTopography. And so we see this really interesting diversity of use, and we always love it when people tell us about stuff they're doing. So if you're doing something with OpenTopo data that's really interesting, and you're going to share it on Twitter or Instagram or whatever, you can tag us or send us an email. We always love to hear from people about what people are doing. And there's a lot of really interesting things in the kind of like virtual world, gaming, AR, VR space. 3D printing is a really area of a lot of interest. There's a lot of kind of recreational and hobby uses of these data that are quite fascinating. Another thing that we won't dwell too much on, but it's just to talk a little bit about use, how people use these data sets. So Indiana, we've been hosting data for the state of Indiana since the early 2000 teens. And this is a map showing spatial utilization of these data sets. So when you have a statewide data set, people don't use the data consistently. So this is a heat map of how people use data, which is kind of interesting. And then temporal use. So basically, how do these data sets get used? And one of the things that's maybe not that surprising to you all out there is that these data sets have a lot of value for a long time. So a data set collected in 2011 is still getting heavy use in 10 years later. These data sets don't decay in utilization like some other things on the internet do, like YouTube videos have a pretty steep decline in use, for example, or watching. People come back to these data sets over and over again. And so there's spatial and temporal reuse of these data sets. It's really kind of fascinating to think about. And this heat map is available for every single data set in OpenTopography. So there's a little button in the upper right of the map that says view heat map. And we compute these on the fly so you can see where people are using data. As I mentioned, we've done a lot of work on education and training. It's short courses. We're constantly working on videos, video tutorials, and other things. This is always a bit of a struggle, but trying to stay on top of tutorial content. But there's a lot of things on OpenTopography's YouTube channel and in the Learn section of the OpenTopography webpage. We also have been developing a variety of classroom exercises. So if you're an instructor, we have a variety of interesting resources about sort of pre-set curriculum you can use in a classroom. We do some higher, more advanced courses as well. This is an advertisement for a short course we're running in Tempe, Arizona, May 8th to 10th. The application is going to go live for this probably at the end of this week. We'll have a space for about 50 people, but this will be a much more advanced sort of training you on sort of building workflows and processing these kinds of data with a very earth science centric focus, because this is supported by the National Science Foundation. For those who want to dive in a little bit deeper on sort of like technical or more advanced use cases, we do in our GitHub repository provide quite a few different kinds of Jupyter notebooks that we've been developing, and also some code snippets around things like topographic differencing and other and some algorithms and other resources. And so the OpenTopography GitHub is a cool repository of stuff, and this is always growing. We've recently had a couple interns in the past couple summers who've been building things and specifically notebooks, and those are all getting published here. One example that's kind of fun and that I've had a lot of fun playing with is this product called the RiverRem. It's a Python package that was developed by an OpenTopography intern last summer named Kenny LaRue. And this is to produce relative elevation models programmatically. So these are detrended topographic models. And they're very pretty, especially in places like meandering river channels. So this image in the background is a river in Texas. And what these relative elevation models do is help you to accentuate and visualize sort of the topographic differences in lower relief landscapes. And so this RiverRem tool is quite fun if you're somebody who likes to look at these things or you want to make pretty images. You can grab the Python tool package and grab some data from OpenTopography and run it. It's pretty straightforward. And it will produce these products, including like the color maps and all these things. So just a relatively new resource that's kind of fun to look at. Another thing that we get a lot of questions about is 3D printing. There's a lot of people now who have access to 3D printers and are interested in making 3D models, whether that's for recreational purposes like 3D printing your favorite rock climbing location, or it's for an educational purpose. Emily Zawacki put together a really nice tutorial on how to use data from OpenTopography to produce 3D printable models in QGIS. This is another resource that every time we point people to it, they seem quite enthusiastic about. And so I just wanted to put that out there because I know that's a topic of interest for a lot of people. So this is the second to last slide. So just like some high level takeaways here is that, OpenTopography is about access to data, but really it's about making the data easy to use. And that's this kind of on-demand computation of products. We also are really interested in providing different pathways to data. So that's things like APIs for these global data sets, Jupyter notebooks, other kinds of resources. There's a lot of resources for training, and you'll learn more about those if you continue to attend these webinars, hopefully over the next 8 weeks. And one of the things you'll hear talked about later, especially with regard to the topographic differencing work, is that we're getting to the point of having nationwide, at least in the US, high resolution topographic data. And that really creates a lot of interesting opportunities to really scale up analysis and start looking at various phenomena over larger scales. And so this is a really interesting opportunity. It presents a lot of interesting kind of cyber infrastructure computational challenges about how you build workflows to do this effectively. But it's something we're really interested in doing more to enable. And so this is definitely a growth area for us. And then the last slide is just to say thank you and to encourage everybody out there to please come to the future webinars, because I went quickly through a lot of things, but our goal is to go back and touch on a lot of these things more deeply and make sure you get a deeper understanding of how these tools work. We also, as I said, love to hear from people. So feel free to send us an email. That's info@OpenTopography, goes to the team, and we will do our best to get back to you as quickly as possible. We exist on all the social media platforms, and it's usually just @OpenTopography. And if you're doing interesting things or using our data, please tag us. We'll help promote your work. And we just like to see what people are doing. If you've got feature requests, problems, bugs, like send us messages. We really are very interested in engaging with our users and trying to better make OpenTopography match what people want. And so I'll conclude there and turn to the QA. It looks like there's been looks like the team has been cranking away answering questions. So feel free to toss other questions in there and I can answer them out loud, or if other folks on the team want to point out questions that have already been answered that we want to revisit, I can do that as well. Anything?
Maybe Chris, if I was just trying to answer this one about, do we have online courses for the advanced workshops?
So this RCN workshop, the one that I gave a little advertisement for in Tempe, is only in person, in part because we want to stimulate kind of early career interaction among participants. And so that's in that case. But if you go and look around in OpenTopography, there is quite a bit of, we've previously done workshops. There was a workshop in 2018, very similar to the one that's coming up. And we recorded all the lectures, and they're on the OpenTopography in the OpenTopography webinars channel, I think, and on YouTube. And so you can find that information there. what else?
I'll toss one to Chelsea if she is willing to answer. There's a question about identifying ground motion at the centimeter level, and there was also one earlier about coverage in Central California and characterization of subsidence. And I answered just that we didn't have great coverage overlaps in Southern California, and I mentioned something about data resolution. But maybe Chelsea, can you talk a little bit about ability to resolve change with, let's say, repeat LiDAR?
So the main advantage of using LiDAR to resolve change is that the data set has a meter scale, often resolution, and can detect quite large amplitude change. So for example, new buildings or large landslides that may often decorrelate with INSAR. And the data do have much greater spatial resolution than GPS. The downside of LiDAR is that the time resolution in most areas is quite limited. And so in different parts of California that are not along the coast, there are some cases where there are 2, maybe even 3 data set overlaps, but we won't get quite the resolution that, say, INSAR would have to resolve these changes. And on the uncertainty, so these differencing exercises are limited by the error in the original LiDAR data, but a good sort of ballpark is, it does depend on the data quality, but tens of centimeters of change or larger is likely to be observable. And the uncertainty will be lower with newer LiDAR data sets that typically have lower error.
Thank you. How about some?
Thanks, Chelsea.
We had some. We blasted through a bunch of
yeah.
Let's see. Maybe Emily, you or Matt can send a link to the Tempe workshop.
Yeah, it's under learn/workshops or something like that.
Yeah.
And again, that one we'll announce that also when the application is open for that, we will announce it via social media and also via our newsletter, which I saw Emily. If you're currently not subscribed to the OpenTopography newsletter and you want to kind of keep up on what's going on, that's probably your best way to do that. The easiest way is just to go create an OpenTopography account. And then when you create that account, there's a checkbox that allows you to subscribe to the newsletter. But that's an easy way to sort of find out. We usually put what data sets are available in the past month and other goings on, things like community workshops, webinars, etc. Anybody else have questions? Got a few more minutes. Feel free to ask anything.
Just going back.
Yeah.
There was a question maybe you could speak to, Chris, about bathymetry. And we kind of answered it, but
I saw Matt answer that, but let's go back. Okay, yeah, let's see. So there's what one person was pointing out that NOAA has a system called the Digital Coasts system, which is excellent and very much like OpenTopography in a lot of ways. It has similar tools for doing things like producing products sort of dynamically from the source data. Now that NOAA is publishing a lot of their data into these these Amazon buckets, I think we have a lot of the same data that NOAA is exposing. So in some ways, it's sort of where you perhaps find where you prefer to use and access the data. Generally, another, I guess, higher level question that was asked here was sort of like, a lot of these data sets, OpenTopography is delivering them as they were collected or as they're being distributed. And so we don't go back into sort of data sets and necessarily do a lot of QA, QC or improve them. So we're not like reclassifying data sets. If the data are sort of well described and meet sort of basic file level QA, QC validation, they generally appear in OpenTopography. And so there's it's a fairly heterogeneous archive. LiDAR as a technology has evolved a lot in the past, whatever, like 20 plus years. And so there's some old data sets in OpenTopography. They're definitely, uglier and have lower point densities and things like that. So not all LiDAR data is created the same. And so that's definitely something worth being aware of. I saw Dan asked a question about implementing more complex processing in OpenTopography. And so it's a great question. It's something we're definitely interested in doing. You mentioned Topo Toolbox. I think, Ramon, you said this, but actually the OpenTopo API is integrated into Topo Toolbox. So you can just go use your OpenTopo API key and pull topographic data straight from the OpenTopo API via Topo Toolbox. And a lot of this move towards trying to publish data sets in cloud native formats like COGS is meant to enable you to kind of hit our buckets of data and process them. So I definitely encourage you to check out that Jupyter notebook that Matt put together. Maybe somebody can find that notebook and toss it in. Somebody's got a browser open. Toss in the chat to point out that resource. What else have we got? Somebody asked about Potri. I see there's a link there, and actually Ramon's going to lead a Potri and cloud compare tutorial in a webinar in a couple of weeks. So come back for that one. Academic internships. We definitely do internships. We do them through the EarthScope student internship program. So the summer interns for the summer just closed, but we have a lot of applicants, 45 or 50 interested applicants, and we will be reviewing them. And so stay tuned. And those are definitely something that we promoted in the newsletter and also via social media. So if you, again, are interested in future summers, check that out. Let's see, what else? The questions about sort of other global data sets is another common question. So there's LiDAR data, high resolution topographic data in lots of different parts of the world now. Europe has increasingly good coverage. A lot of those data sets are open. There's some data in places like Mexico and also in Southeast Asia, but the openness of that data varies. Some places have data, but it's not open or it's not easy to get. In other cases, it's just the like DEM derivatives and not the point clouds. But you're not going to find all that data in OpenTopography largely because we just don't have the resources to go and chase all those data sets down and put them into OpenTopography. We'd love to. It'd be awesome to truly have all the data for the whole world. But at the moment, that's a little bit out of reach from a funding perspective, because as you can imagine, these data sets are large and the compute resources on top of them in order to do this also takes a fair amount of resources. So we're working on it. But if you're aware of cool data sets and you want to share them with us, definitely get in touch. And we review kind of interesting data sets on a case-by-case basis as resources allow.
One thing, Chris, is maybe just we should remind people that if you go to the OpenTopography website and you click on data, you can explore a map-based view of the data. So there's some questions if there's data in one place or another. Yeah. And you should just go and look.
That's this one. My screen is still shared, but not in presentation mode. So this is the data map in OpenTopography, opentopography.org/data. And this is interactive. And so anywhere you draw a box on the map, you'll get a result below the map that tells you what's available. And so pretty much anywhere on the planet, you're going to get global data sets, these SRTM types of data sets. Any chance you'll host Asterdem global data? I think Matt's also typing, but we have the AW, the Aster World 3D data set in OpenTopography. So that's the AW30 3D. So it's a 30-meter resolution global data set. There's also, then there's the Asterdem, which I believe that's one that has the license. Some of these global data sets, depending on how they've been produced, have pretty restrictive licenses that make it really hard for us to redistribute those data sets. And that Aster Dem, I think, is one of them. I'd have to revisit this, but I think when I looked at it, there was something about not redistributing the data if you can recover the X, Y, Z pixel values or something, which makes it really hard for us to do. So that's perhaps why Aster Dem's not in there, but Matt just pointed out that we'll look at it again for sure. But definitely, if you're somebody working with global topographic data sets, the data sets I point people towards most commonly are the NASA DM, which is like a reprocessed version SRTM, and the Copernicus 30-meter DEM, which is a new product, relatively new product. It's essentially global and is, I think, regarded by many people to be the cleanest and best of the kind of global 30-meter DEM products. Okay. Anything else you want to answer? We got a couple minutes before the top of the hour.
One question here about EarthDem and 2-meter optically derived data for Nepal, but what any sense of access to EarthDem?
Yeah, good question. So EarthDem is one that we've been talking to the Polar Geospatial Center, the people who produce that product, about this. A lot of those the EarthDem data sets, like the Nepal data, are only available through the NASA SmallSats program, which is restricted, I think, to governmental employees and people funded by the government. I don't know if somebody who's got a browser open can quickly Google NASA SmallSats and toss that link in there, but it's a NASA program. But there is the Arctic DEM and REMA, the reference model for Antarctica. And both of those data sets, there you go, thanks, Dan. Both of those data sets, we're working on getting into OpenTopography. We actually have Arctic DEM currently in our beta environment, and we're testing it. And so that will be, that will hopefully be coming soon in OpenTopography. But some of those data sets, currently the bounds on EarthDem are such that they'll never be publicly accessible due to the licensing restrictions, I think mostly related to the source imagery that's used to produce them. So that's a great question. Thank you. Any other questions before we wrap up? Let me jump back here, since I'm still sharing my screen, to this and just put this back up here to remind you what's coming. So if you're interested in the fundamentals of sort of point of these data sets, point clouds, where they come from, more specific details about point clouds, we're going to do that next week. Matt Beckley will lead that. And then on the 29th, we're going to do digital elevation models and talk about those and how more details about how you use them in OpenTopography. And then April 5th will be the 3D visualization. So this will be that web-based browser tool for looking at point clouds. And also, I think we're going to talk about Cloud Compare, which is an open source software package for point cloud data visualization and analysis. Chelsea will talk about topographic differencing, a much deeper dive on that topic on the 12th. And then Emily will do hydrology and topography tools, and that's sort of flow routing and other things, 19th. And then at the end of the series, we'll do the educational and training resources and 3D printing on LiDAR. So that's the plan. Please reach out if you have any questions and join us in the future. So thank you all. I think we're going to wrap this up. Okay. Talk to you all later.